And speaking of migration, it's actually what our next session is going to be about. So that question was a great transition to what Alok and Andrew are going to talk about today. And they're going to talk about how to basically migrate in real time to Cosmos DB. So now I'm going to turn it over to Alok to talk about online and real-time database migrations to Azure Cosmos DB with Striim.
Hey everyone, this is Alok and Andrew here. My name's Andrew. I've been working on the Azure Cosmos DB product for about the past 7 years. And over the years, I felt very, very blessed to work with many developers like you. In this session, I'd like to cover one of the most common challenges I frequently see in modernizing applications. And to set some context on this, the common use case I frequently see on why developers choose Cosmos DB over traditional databases is to take advantage of its distributed nature. If you've worked with data at scale before, this is frequently known as the partitioning and replication problem. And Azure Cosmos DB provides the ability to automatically scale out via partitioning, or known as sharding, which enables our applications to remain highly responsive even when they grow to massive scale. In the previous session, Kirill showed us how Microsoft builds applications like Microsoft Teams on Cosmos DB, which allows the underlying data tier to scale to trillions of transactions per day while maintaining latencies measured in single-digit milliseconds. I also frequently see developers leverage the other distributed aspect of Cosmos DB, which is replication, in which we can easily build applications that enjoy a high degree of availability and resiliency. And this is achieved through redundancy by replicating that data live across numerous data centers. Now, a question that I'm frequently asked is, how do I take advantage of Cosmos DB for my existing mission-critical applications? More specifically, how do I facilitate live data movement from my existing legacy database? Can we do this while keeping our applications online and avoid lengthy maintenance periods? What if that data is coming from a traditional relational database? The data model on my relational database tends to be highly normalized, in which we optimize for storage over compute by shredding and joining that data across many tables on each request. But in Cosmos DB, we're taught to revisit how we think about data modeling, which we need to optimize for compute in the form of RUs instead of storage. This is achieved by denormalizing that data, in which relationships are represented through nested objects and arrays instead of joining across tables. Moving from normalized to denormalized data requires quite a bit of data transformation. Can we do this as part of our live data movement process? So to solve this problem, I've had the great pleasure of working with a very, very good friend of mine, Alok, who is the founder and chief product officer at Striim. Striim built some amazing tooling that targets solving this very specific pain point. So Alok, it's very, very nice to have you with us. Would you like to tell us more on this?
Sure, absolutely. Thank you so much, Andrew, and thanks a lot. Hope everyone's enjoying this virtual Cosmos DB conference. I'm really delighted to be part of this. And let me pick it off from where Kirill and Andrew left off. And so in this session, in the next 30 minutes, I'm going to be talking about primarily the data movement and the data migration problem that was just touched on. I'm going to start off with a platform overview. So that's going to give you some idea about the feature functional capabilities of what can be achieved and how to set up the actual migration and the integration data pipelines. I'm also going to point out some of the challenges along the way, as it comes to both the denormalization, moving data from your legacy systems onto Cosmos DB. How do you do mapping between different, for example, from one primary key to a partition key? How do you scale the workloads and so forth? And I'm going to wrap up and I'm going to try to show you a couple of demos. Hopefully, I'll have time to show you both. So with that, let's get started. So first about Striim. Striim is a partner, and we've been working with Cosmos DB for several years. So we enable continuous enterprise data movement to the cloud. And the core idea is that you might have a number of different applications running against different types of database systems, NoSQL systems. Many of them could be running on-premise. They could be running in other clouds. And oftentimes, to sort of take advantage of the very low latency access in a distributed fashion for the Cosmos DB workloads, you want to move the data into Cosmos DB. So what we do is we facilitate that. And the core focus that we have in line with why you want to deploy a lot of these applications on Cosmos DB is the real-time aspect of it. Now, if you sort of take a look at the picture to the right and take a look at data as an iceberg, there's ways to come at the data directly through the APIs of the application and then move that onto, let's say, a system like Cosmos DB. But oftentimes, when the data volumes are super high, and we're really talking about tens to hundreds of thousands of events per second in a traditional legacy database, then how do you actually come at it from an API that's at the application level? That becomes a critical challenge. So oftentimes what people do is they tend to come at it more in a batch basis. And what that does is it introduces latency between the traditional system and Cosmos DB. And that's one of the things you're trying to avoid because of the sensitive nature in terms of low latency for many of these applications. So one of the sort of the revolutionary techniques here is something called change data capture and the ability to stream in a very non-intrusive fashion data from many of these systems into Cosmos DB. So I'm going to spend a significant amount of time getting into that area today. Okay, so just overall to set the stage as to how the pipelines would work, and as developers, how are you guys able to work with Striim as a platform to ultimately work with any one of the APIs for Cosmos DB, any one of the different models, and then stream the data there? Let me just set up the high-level picture. So you have a lot of different applications that you're running today. They could be running on databases. There could be some applications that are generating log files or writing data to messaging systems, which could be, for example, Kafka. And data could also be coming in over different protocols, let's say TCP, UDP, HTTP, etc. So within the platform, the entire orientation of building a pipeline is having a drag and drop type of an interface. And then at the back end, there's Java code that actually gets executed for continuous data collection. And at a very straightforward type of a pipeline, you can continuously collect this, and you can actually deliver this into different collections onto Cosmos DB, into different containers. More interestingly, as you start moving this data, Andrew talked about some of the challenges that come along. You might have, very normalized data, and then you want to sort of split that up and write different portions of that data to different containers. Or you want to coalesce it sometimes so that you can bring it together into one container so that you can have denormalized access to that data for your applications that are running on Cosmos DB. So one of the things that you can do is as the data comes in, you can either event by event or on a state like a little window, which is temporal, or it could be batch based. You can hold that data, and this is all happening in memory, and you're able to apply a number of different transformations or aggregations or enrichment, or even join this with data that is reference data. And this is one of the critical requirements that often come, we face as developers, where we want to move the data to sort of, create the overall document as we move the data. So in this example, you can see that logically you're able to not only transform the data that's coming in, you can also, massage it using an external context. So you could preload data from additional sources into the Striim platform. And now you can literally join that data, as you take that data. This might be, for example, for enrichment of that data. Some more advanced capabilities might be there are operators. One thing I should have mentioned is that a lot of the capability is through the UI. So you are able to actually, and I'm going to show you that later, you're able to take a lot of the operators that we have and apply that on the record itself or on the window. And if you wanted to extend it, you're also able to write your own queries in SQL, or if you wanted to do some advanced integration with your own machine learning models, for example, because the model might want to give you a value that you want to store as part of that data, then you're able to also write your own Java code, and you can actually link in with that. Along the pipeline, so again, just stressing on the collection piece of it, the transformation piece of it, and the transformation could involve multiple different tables, for example, coming in from an Oracle database or a SQL Server database, MySQL database, and you can actually massage it, or you could split it apart and then give that as different event streams to the platform, and each event stream could then be talking to a different container. And we'll get into the guts of that. I'm just trying to set up the high-level picture here. Along the way, there's a lot of operational monitoring. So there's a lot of debugging capabilities that you can take a look at the kind of the image of the data that's coming in. And once you actually apply the transformation operator, there's also a post view of that record. So let's say if you have a record that's coming in, which is a straightforward tuple from a relational database, you can actually convert that to a JSON object, and you're able to actually visualize the JSON object along the way prior to delivering that over the API on the Cosmos DB side. Okay. So let me just quickly get into why is this interesting, and where do we see a lot of our joint customers who have these development teams struggle, and what are the challenges they're trying to solve. So I think some of them are mentioned. Obviously, you might actually be trying to sunset an application that may be running, let's say, in a legacy database like Oracle. You might actually have data coming in from a NoSQL system like MongoDB, and you wanted to do a migration and eventually phase that application to Cosmos DB. You may want to do data denormalization, like I mentioned, where it's not your goal may not be to sunset an application, but there's a new application that's being deployed to kind of do digital transformation or data modernization, and as part of that, you want to sort of have a brand new application run on Cosmos DB. Real-time telemetry and event feeds into Cosmos DB. That's another critical use case. And this has to do with the ability to ingest at very, very high volumes. So typically millions of events per second, if that's the kind of use case that you have. Doing parallel reads. If you have a Kafka cluster and there's a large number of partitions, then how do you actually go in and do continuous data collection across the Kafka topic, which may have hundreds of partitions, using a very simple pipeline that allows you to capture the data continuously and then move it to the Cosmos DB target system. And lastly, even if you have just normal JSON data that's coming in from some application in a file, or maybe over some network protocol, then you can actually take those and then also move that onto the Cosmos DB side. So these are sort of what I call the use cases, if you will, which are meant to be addressed. Of course, we are focusing today on the migration and the data movement, which is very real time, so that you can ultimately you have maybe let's say an Oracle system running. You set up your Cosmos DB system, and then you sort of sync them up, and ultimately you're going to pull the plug and then just have a new application running on the Cosmos DB side. Okay, so let me just quickly get to how is this actually done. So typically the objective is, hey, I want to migrate some existing tables or collections, let's say from Mongo, with an intent to cut over to the Cosmos DB database. And the idea really is that, hey, I may want to just completely migrate or keep the two sides in sync. And along the way, there's these transformation and let's say denormalization capabilities that I want to actually introduce. So typically there are two things going on here. One of them is, how do I do sort of like a scaled instantiation, or often known as an initial load, where you might have existing data for a decade or 2 decades, and you want to now move all of that data over. So you kind of have an initial snapshot. And the other aspect of this is, well, what happens, because you can't really take downtime, so the data is actually changing on your source system. So how do you accommodate for that data? And that's is the synchronization phase, right? That accommodates for your ongoing changes. So within this synchronization, there's a couple of things that you face, as when you're developing these pipelines. Number one is, how do I keep it real time? Because like I mentioned, if you're going to go take a batch-based approach, then oftentimes you don't want to impact the source database, which is running a mission-critical workload. So you're going to add a lot of impact and overhead if you're constantly pulling that the system to detect for any delta changes. So that turns out to be a non-starter typically. Number two is, you do want to have some sort of a high-speed interface, and that's really what oftentimes people want to use an interface like CDC, which is a change data capture interface. And many of these systems allow you to have an API where you can mine the transaction log or the redo log, or maybe the ops log, and then you can actually take the changes from there. That turns out to be one of the most efficient ways in which you could grab the event stream for applying on the target system. The other part is that you want to make sure that you're able to keep the two sides in sync, which means that not only are you collecting the data, you're also applying it using the APIs on the Cosmos DB side, and you have to be able to parallelize that, the writes to different containers. So you want to make sure that you're able to keep up, in near real time between the two systems, so that ultimately you can actually fail over or cut over to the Cosmos DB side. Okay, so these are kind of some of the synchronization challenges. So let me just talk about what is the big deal here. Why, what is the complexity here? So oftentimes, right, people are not going to allow you to put triggers on the source system, because that turns out to be just super expensive on a critical application that's running on that database system. So the problem with the log records is you're not writing them as you're applying records to a table. Typically, these are very compact binary representations of the change vectors that you produce against data blocks on the actual tables, which are represented and coded as redo records in the transaction log. So, that structure, you need to interpret that, and then you need to be able to map that onto, the model on the Cosmos DB side. And that turns out to be challenging. You have to write a lot of code, you have to understand the format, and that's not that simple. Oftentimes, you might do things like partial updates. So if you do a partial update, then what happens if you already have a complete image of that document in Cosmos DB, and now someone just updated, let's say, on the source system, just 2 of the columns out of the 100 columns? Well, then the document that I construct might be a partial document. So how do I deal with things like that, right? So these are the things that you need to pay attention to. If there are failures along the way, then what are the event guarantees in the change data stream? Am I able to pick up things from where I left off, or do I have to worry about writing the logic to figure out where things are? So these are, again, some of the complexities that come in as you're trying to handle the change data records. One also very interesting thing is that many of the underlying databases may not give you the changes in a transaction commit order. So they might actually be writing the records in an interleaved fashion in the redo log. So, and then ultimately the transaction possibly could even roll back. So if you're mining the changes in real time, then you also need to assemble them so that you may have like a complete transaction. And then you need to map this transaction. For example, if it goes across an orders table, and then also like a line item table, then you want to have that be represented in maybe one document. So then you need to strip out portions of the values from those records, and then create a document and then move them forward. Okay, so these are sort of some of the interesting things that come up as you're dealing with the CDC in your pipelines. So in Striim, how do you do this thing? So my next few slides are going to talk about that. So what we've done is we've sort of given a visual environment where there are pre-built wizards. So you can see that there's wizards from MongoDB to Cosmos DB, and Oracle CDC to Cosmos DB, Microsoft SQL Server, and there's really a lot of the popular sources that you want to develop for. So the idea is that you're starting off with saying, here's my source, and then you're able to write, as developers, either you can take our pre-built functions and apply those to the pipeline, or you're welcome to write your own in SQL or in Java. If, let's say, I mentioned, if the out of the box function is not satisfactory and you really want to invent your own interesting algorithm to maybe massage the data, oftentimes that may be required, particularly if you are denormalizing the data across multiple different sources, because it might require custom logic. So you pick one of these wizards, and the way this thing happens is in 3 high-level steps. And I'm going to show you the demo as well. So you select the source. So out of the box, you can actually select a number of different sources like Oracle or MongoDB or MySQL or Postgres or Kafka, etc. So in this case, I've selected maybe the Oracle reader, which is getting my inventory data. And then there's a designer palette which allows you to say, hey, am I trying to transform an event that's a normal event coming from a file, or is it coming from a database? So the database event allows you to deal with the CDC record that I mentioned earlier. Because remember, that is not specific to a single table. So its schema doesn't conform to just one type. You might have changes to hundreds of tables, but they're all being represented as one logical change record. So we have operators that allow you to massage that data in that logical change record based on these database event transformers. So you can actually add your own custom fields. You can modify the data. You can add your own metadata if you wanted to, oftentimes, because sometimes we've seen cases where there may not be a good partition key. So you want us to add your own key along with the data record, so that on the Cosmos DB side, we're able to be super efficient and get to the right partition and identify the subsequent record. Okay, and step 3 is there's a writer piece of it. So far there's a reader, there's like this transformation capability, and this is a very linear, simple graph. You could actually, the middle tier here could have like 10 different components, and you could have a kind of a fan-in model back into a data stream, which is then talking to the Cosmos DB writer, which is another component within the Striim platform, and that's the one that actually leverages all of the APIs to then finally deliver the data onto the Cosmos DB side. Okay, so with this, this is sort of like how you set up the configuration of the pipeline itself. And there's like a lot of useful functions there that you might want. For example, if you want to do some aggregations, or if you want to do split records or mask records, you can do stuff like that. We do support all of the popular APIs that Kirill talked about earlier. So if you're familiar with the core SQL API or the Mongo API, Cassandra API, we support all those APIs. These are within the Cosmos DB writer, okay, for Striim. So the incoming data format, this is an interesting point. I think I talked about this briefly. So the incoming type could just be a straightforward record that's coming from a table. It could be coming in from the actual transaction log. So in this case, you can see that not only do you have the data, but you also have the metadata, things like the table names and the redo byte address where the record was generated, and the system commit number, all those things that the transaction log keeps track of. If the data is coming in from MongoDB, then again you could have just the document itself, which is coming from the collection, or you could have the ops log record, which again has the data and the metadata. And these are just for your convenience, because if sometimes you may want to add some metadata as part of your collection, before you apply to the container on Cosmos. And finally, it could be just coming in as straight through JSON documents from a file or from Kafka. Okay. So I think we have about 7 more minutes, so I'm going to speed up. These are my last couple of slides before I get to the demo. So the idea in Cosmos DB Writer, which is the main component, which is leveraging the APIs, we receive the data from the data sources. That's coming in as an event stream. You can join that with a data preloaded from a cache in Striim. There's a data structure like that. Or we can even do lookups to an external system. Let's say over an API like JDBC, grab that, and then you can actually go ahead and apply that. Supporting and writing different tables to different containers is supported. We can replay inserts, updates, deletes that are coming in from the source side. And mapping is just supported pretty much out of the box. There is advanced capability. So if you wanted to map specific columns to specific fields, then you are able to do that as well. Finally, just from a scale point of view, Striim can run as a cluster. So it can scale up with similar to Cosmos DB. Literally, we're moving billions of records over a day at many of the retail sites worldwide. And we do take advantage of batch optimizations in all of the APIs for the various models that I mentioned earlier. Okay, so with that, I'm going to give you a demo. I have about 6 minutes. So let's actually step into the Oracle to Cosmos DB demo first. Okay. Perfect. So this is a recorded demo, so I have the luxury of actually pausing and highlighting some interesting things that you might be interested in. And of course, please feel free to send questions as you dig deeper into this thing. So this is the, so there is a web server as part of Striim, and we're just connecting through the UI. The apps represent the pipelines. So I'm going to step into the apps. And here you can see that there are two pre-built pipelines. One of them is called Aura to Cosmos. The other is CDC Azure Monitor app. Okay, so let's step into the Aura to Cosmos app. Okay, so once I step into the flow, let me just pause this. You're seeing top to bottom a graph, and this is how the data flows from the data source into the small component with the squiggly lines. That's a stream. So the stream is sort of where each one of the records comes in. And then there's another component, which is enrich CQ. That's a continuous query that's constantly and continuously enriching the event that's coming in. And then it's going to go write it to two ways, one to Azure Blob Storage and the other to Cosmos DB. Okay, so, and the way this is built is by doing a drag and drop from the components on the left side, where we have support for lots of different sources to talk to your Cosmos DB target. Okay, that's how this graph itself was generated. Okay, here's the operators that I was talking about earlier. So let's step into, this is the configuration panel on the right side. Here's where you can actually say, hey, what are the tables that I'm interested in moving live to Cosmos DB? In this case, I mentioned earlier that you can enrich your data. So at the top, if you take a look at the Oracle Reader, that was where that's the connection to the database. The other one is this sales rep cache. So we have some preloaded data from, in this case, just let's say a file. And you can actually join across these two based on the rep ID, the sales rep ID, because the name may not be available, and we want to push the name into the record. So this is an example of how you can actually, denormalize some of the data, and then and I'll show you the query as well in just 1 second. Okay, so this is currently we're looking at the cache definition here. Okay, let's take a look at the query that does the join here. So you can see that I'm just writing a simple select statement across my Oracle source as well as the sales rep cache, and then I'm joining that on the rep ID so that we can pull up the rep name. Okay, and then let's just go forward a little bit on the targets. I'm going to jump into the Cosmos DB side. That's where you provide your access keys, etc., and the mapping capabilities on the Cosmos DB. Let's go ahead and deploy this application. And once I deploy it, I'm going to start it. The start of the application is what gets the data flowing. I had mentioned earlier that you can actually preview the data. So in this case, once the source starts feeding the data, you can actually start previewing, and you're seeing the actual, the records that are coming in. And you can see that I pulled in the sales rep name as well from the cache. So far we're getting this data and we're previewing it. We're going to then take this data, and then depending on which API I'm using, it's going to actually go ahead and format that and push that on the Cosmos DB side. So let's take a look at that. Okay, so here's I'm logged into the Cosmos DB database, and you can see that the specific orders and the items are available now on the Cosmos DB side. Okay, and the similar to this, I showed you the Oracle demo. We have about a minute. There's a lot of monitoring capability here. The key, I'm going to skip past some of this stuff to get to the interesting pieces that you as developers might be concerned with. So you want to often see what is the resource usage. Is my data on an aggregate basis? Let's say I'm moving so many events per second. What is the rate at which I'm applying it to Cosmos DB, so that you can scale into parallel flows. A lot of that capability so you can configure and scale the Striim platform along with how many containers you're writing to, and also depending on the data that's available from your source, depending on the throughput that you're receiving there. So I'm going to stop there. I don't think I have time to get into the second part of the demo, which is the MongoDB reader. It's very similar. Let me just give room for just maybe a quick question or two if we have the time, because it's about 10:29. If you do have any other questions and comments, you can go to our website at striim.com, or you can also go to the Azure Marketplace and just take it for a spin. So both options are available. And with that, I'm going to take any questions that might be there. Thank you.